How has
Hmm.
artificial intelligence evolved over the years? Like, can you give me a brief about the history?
So, artificial intelligence, the big changes that you're seeing right now, um, isn't any new algorithm or any new math that's going behind it. The reason that you're seeing this is because of two changes. One is a massive increase in the computational power that we are able to muster thanks to GPUs and like really much faster CPUs. And the second thing is how we have architected the math around how these neural nets are trained. So those are the two big things that has caused like all of the recent like crazy growth in artificial intelligence. But if you go back to where it started, uh, one of the first implementations of an artificial intelligence, so to say, was by a guy called Frank Rosenblatt. He created this single neuron called a perceptron. And essentially, what he was trying to do, if I remember correctly, was he was trying to distinguish between images. And he was trying to do this in a way where he wasn't telling the computer what to do, but the computer would be able to figure out by itself what it was doing. And he used how the human eye works as an example to kind of architect the system. So the way that he did this was he essentially created a big circuit board of um, like a big circuit board and like connected wires to every single point on it, and then gave this system examples of what it could do or what was correct, what was actually what we today call labeled images, and over many cycles it slowly taught gave it an algorithm to slowly tune its weights so that it kind of got closer to what the right answer was. So this is a very basic implementation of a neuron, but amazingly it kind of worked. And he maybe would have done a lot more, but I believe, if I'm not wrong, Frank Rosenblatt died at a very young age, like around 35, 40 years old. Um, but that was like one of the first artificial intelligence neural nets, so to say. And if you take like one step even before, the first implementation or first thought of like what a neural net or what a neuron does came when we discovered how the neuron in a cat retina works. One of the first implementations was to understand that a neuron is essentially like connected to other neurons, and based on the input, it decides whether to fire or not to fire. So we kind of understood that by observing and looking into the neuron in a cat brain. And that led to the thought, oh, if this is what it does, could we not simulate this mathematically? And that was one of the first thought of like, okay, this is what a neuron could do.
Hmm.
Frank Rosenblatt then actually built a machine around it, and
Hmm.
um, after that, so that was the implementation of a single neuron you could think of.
Hmm.
Then the thought came, okay, what would happen if we start layering neurons one after the other?
Hmm.
You could do more interesting things. But a
Hmm.
big problem during all of this was, how do you train a neural net? Like, okay,
Hmm.
like the architecture kind of looks similar to how the human brain works, but how do you actually train it? Because we don't understand how we train our brain.
Hmm.
So, in around maybe I'm a little off with the time frame, but the late 80s or the early 90s, um, a group of researchers came up with the backpropagation algorithm. Now, the backpropagation algorithm is very fundamental to all neural nets. And what it does is it basically is an algorithm that tells a long neural net that if this is the right output, how do you propagate the error backward? So that if
Hmm.
you propagate the error backward, then each neuron knows how much to correct itself by. This sounds very simple, but it's the algorithm is not very complicated, but the fact that we were able to come up with is pretty cool. And these two innovations, which is okay, a neuron is a weighted sum of inputs, and two, you can, based on the right output, you can propagate the error backwards, and then each neuron can figure out how much to correct itself by. These two innovations were responsible for a lot of like the crazy growth in artificial intelligence.
Right. And could you explain a little bit, in very simple terms, like how do modern AIs work, for the mass audience that doesn't know anything about them?
So what they're doing is, so we talked about what a neuron does, right? A
Hmm.
neuron basically takes a weighted sum of inputs. So if there are two inputs to a neuron, then each input has its own weight associated with it. Then you do a weighted sum, and if that weighted sum is above a certain value, the neuron fires. If it is below that certain value, it does not fire.
Hmm.
Okay, that's what a neuron does. That's what a mathematical or an artificial neuron does. Now, the really cool thing about this is if you take this simple thing and you structure them into layers, they start understanding language. If you start putting them into sheets, they start understanding images. And if you start putting them into cubes, they start understanding video. So, at the very base of this is a neuron. All it does is it's a weighted sum of inputs. And then if that weighted sum is above a certain value, the neuron fires. If it is below it, it doesn't fire. That's the fundamental concept. Now, what enables the modern artificial intelligence nets to do their thing is the implementation of attention. So, what the modern neural nets are trained on is, if, let's say I say a sentence like, my name, I live in China and my name is Dash. Okay?
Hmm.
Like, let's say that is the sentence. Now, what a neural net is trained to do is take all of the symbols that have come before the dash and use that as the context to predict what the next word should be. So here you could look at all of the words and say, okay, I live in China and my name is. So here you could get a sense that, okay, what you're supposed to output is a name.
Hmm.
But what would be even more interesting is if you could look at all of the past symbols and see which ones are more important in figuring out what the fill in the blank is. So here, for example, I know that I'm saying I live in China and my name is. So the neural net somehow is able to implement attention, which is it's able to look at all of those symbols and understand, okay, the word attention and the word China, sorry, the word name and the word China are more important than the other pieces. So the name that it comes up with is not just some random name, but a Chinese sounding name, because both of those kind of are like put together. Um,
Okay. Okay, it's like a
so
logical sequence where.
yeah,
Okay.
but like previously, like it used to place equal importance to every token that came before it. But now the
Right.
modern nets are able to implement attention, which is they by themselves are able to understand which words in that sequence are more important versus less important, and use that to predict the next word, and then the next word, and then the next word. So like ultimately, what it is doing is it's predicting one word at a time, and it's an auto-regressive model. So it predicts one word and then runs that whole thing again and then predicts the next word.
That's so interesting. It's like I don't know if this example like fits into this picture, but correct me if I'm wrong. It's like let's say there's a massive spider web, okay, multiple spider webs just connected together, and then you drop a ball, okay, on one of the spider webs. Now it goes down onto a specific point, and then from that weightage, it connects to another one, where another ball drop, and then it's kind of connect somehow, but it's
Yes,
that weightage
yes,
is a complicated. Way to sort of think about these things because we don't really perceive language as that.
yes,
And I guess to put it in simpler terms as well, uh, let's use the analogy of a human being. Okay,
Mm.
and